These are the frequently asked questions for Algebra 2 for Section 8.6 Day 2. Looking at number 25, there are a lot of different ways to go after this problem, but as we talked about in class, usually I will just choose to cross multiply, something like this. And again, note, even though it says graphing calculator up there, we are not using our graphing calculators to solve these. We are solving these by hand. So what we need to do is cross multiply this little bugger, which means taking -3 times x minus 4 and setting that equal to 1 times 5x minus 2. And we will get -3x plus 12 by distributing that -3, and of course just 5x minus 2 on the other side. And then we need to start solving. So we're going to move that 3x, the -3x, by adding 3x to both sides. So 12 equals 8x minus 2. And then we would add 2 to both sides and get 14 equals 8x. Then we would divide both sides by 8. And then just do a little reducing to get 7/4. And then we need to check our answer. Make sure that it's going to work. I mean, that's absolutely what we want to see is going to happen. And the first thing we check is, should that have been something that was restricted from our domain? 4 would have been our restriction here, so 7/4 is perfectly fine there. So we're saying that 5 times 7/4 minus 2 over 7/4 minus 4 should equal a -3. All right? Well, 5 times 7/4 is 35/4. 2 is going to be 8/4. So if we take 35/4 minus 8/4, we get 27/4. 7/4 minus 4, well, 4 is the same thing as 16/4. So if we have 7 minus 16/4, we'll have a -9/4. All right, what's next? Well, we need to multiply by the reciprocal because we don't divide fractions. So 27/4 times a -4/9 equals, and in this case, it's supposed to be a -3 there. Well, let's do some canceling. 4's are gone. 9 goes into 27 3 times, -3. There it is. Checks out. It's golden. It works. So again, we need to check our answers. Always worried about extraneous when you're dealing with fractions. Always need to check for that. Now, the next one that I had up here is number 29. And let me make some room by doing some erasing here. So number 29, as I'm writing it down, I'm going to double check that I already have factored denominators on this one. So 2 over the quantity x minus 1, already factored. 3 over the quantity x plus 1, already factored. Equals 4, well that's 4 over 1. So the next step is, let's find that LCD. Everything has to be there and to its highest power, so our LCD will be x minus 1 times x plus 1. And we are going to multiply all of our numerators all the way across by that LCD. Here, the x minus 1's will cancel out and we will get 2 times the quantity x plus 1. Here, the x plus 1's will cancel out and we will get 3 times the quantity x minus 1. And on this side, it's not going to cancel out because we had a 1 on the bottom. So we can definitely put x minus 1 times x plus 1 together using FOIL, and we know that that's the difference of 2 squares, so that'll be times x squared minus 1. Let's distribute. And then it's time to consider what's going to happen here. Well, with the 4x squared, what's going to happen is we are going to have to factor this to solve it, if we can. So let's move everything over to one side, but we'll simplify a little bit first. All right, so over on the left-hand side, we would have 5x minus 1 we still have our little 4x squared minus 4 over on the other side. Now let's get everything over to one side and create a 0, because when we're finding the solutions, we're finding the zeros. And then finally, our hope is that this would be something factorable that we could work with here. We're not guaranteed that, remember, but we're hoping that's something factorable. And if this is something where you're wondering, hey, I don't want to waste a lot of time if this isn't factorable, then do the discriminant. If the discriminant comes out to be a perfect square, then it's factorable. So our b value here is -5. This will give us 25, and then we'd have a -16 times a -3, which would be plus 48, and that gives us 73. That is not a perfect square. This is not factorable. So now what? I'm going to solve it by completing the square. So to complete the square on this one, I would add the 3 to both sides, because pretty obviously that's not helping, or it would have already been a perfect square. And then I remember, wait a minute, in order to use completing the square, you have to have a 1 for a. So I'm going to need to divide all this by 4. All right, next step, find that value that will complete the square. You find that by taking b over 2 and squaring it. Our b value is a -5/4. We're going to divide that by 2, and then we're going to square it. Well, dividing a fraction by 2 is the same thing as multiplying by 1/2, so that'll be a -5/8 squared, which is 25/64. So I need to add 25/64 to each side. Over on the left-hand side, I'm going to go ahead and multiply by 16 for my numerator and denominator, so I can get that to be one fraction at this point. 16 times 3 will give me 48 over 64 plus 25 over 64. So 48 plus 25, we actually had to do that math as we were checking the discriminant there, 73 over 64. And on the right-hand side, I now have a perfect square trinomial, so I need to write that as a binomial squared. And if you're thinking, well, what am I supposed to put in there? Well, what did you square to get 25/64? We squared a -5/8. Now, we need to take the square root of both sides, and remember that we have to do the plus or minus piece. So this will be plus or minus the square root of 73 over 8, because that was a perfect square, and this will be x minus 5/8. So we're going to add the 5/8 to both sides, and our answer would be 5/8 plus or minus the square root of 73 over 8. Now, it said solve each equation and check each solution. If we're going to check this, we need to see what it is as a decimal. So we punch in 5/8 plus the square root of 73 over 8 and get an answer, and 5/8 minus the square root of 73 over 8. And those come out to about 1.69 and about -0.44. And those solutions do work, both of those do. So this is one where we had to find another way. And you could use the quadratic formula instead of completing the square, but no matter what way you do it, you should get those answers as you work through it. Then next up were some word problems here. Number 36 says, you and a classmate have volunteered to contact every member of your class by phone to inform them of an upcoming event. You can complete the calls in 6 days if you work alone. Your classmate can complete them in 4 days. How long will it take to complete the calls working together? All right, so here's what we want to do in number 36. We know that for you, you can complete one job in 6 days. Your classmate can complete that one job in 4 days. And we want to know together, how long would it take you to complete that one job? So this is really just 1/6 plus 1/4 equals 1 over x. And that's what we need to solve. So our LCD here would be 24x. And the 6 would do some canceling here, so we would get 4x. The 4 would do some canceling here, so we would get 6x. The x's would cancel out over here, and we would get 24. So 10x equals 24. Divide both sides by 10, and x equals 2.4, and in this case, our label was days. So you see how this is job, and then how many days it takes you, and you have to use that all the way through the problem. So everything in the numerator is about the one job, and everything in the numerator is about how many days it would take you. So we definitely are dealing with some rational equations for that. Then number 37 is very similar, very similar. One pump can fill the tank with oil in 4 hours. A second one can fill it in 3 hours. If both pumps are used at the same time, how long will they take together to fill the tank? So this one, basically it's just different denominators, but our least common denominator here is going to be 12x. So we're going to multiply by 12x, all of the numerators. The 4 is going to reduce with the 12, and that will give you 3x. The 3 is going to reduce with the 12, and that will give you 4x. And here the x's will cancel, and we'll get 12. So 7x equals 12, divide by 7. And for number 37, probably best to just say 1 5/7 hours, so your answer kind of makes sense, you know. Oh, that's hard to read down there. Let me move that up for you. Not quite that far. There we go. So 1 5/7 hours. Again, once you get the setup with these, it's not so bad. It's just making sure that you can. Number 38, teamwork. You can stuff envelopes twice as fast as your friend. Together you can stuff 6,750 envelopes in 4.5 hours. How long would it take each of you working alone to complete the job? So there are multiple ways to set this one up, but here's what I'm going to do. 6,750 envelopes. And what we are saying is we don't know how fast either you or your friend is. Now, you can stuff envelopes twice as fast as your friend. So we need that X piece to be talking about you, and then twice as long for your friend would be that 6,750 over 2x. Together, that's 6,750 is going to be happening in 4.5 hours. And what we need to do is find our LCD, and in this case our LCD is going to be 9x. So we're going to multiply everything here by 9x. Here the x's will cancel out, and we will need 9 times 6,750, which is 60,750. Plus, here the 2's, we could go ahead and reduce the 9, even though it would just be a little bit weird with a decimal there, but that's what we're working with in this situation. Take the x's out there, and 4.5 times 6,750, 30,375. And over here on the other side, the 4.5 goes into the 9 twice. So we need 6,750 times 2, which is 13,500 x. Well, let's see what happens here. We have 60,750 plus 30,375. 91,125 equals 13,500x. We'll divide both sides by 13,500. And x is 6.75. So That's you. You're the fast one. For your friend, we need to multiply that by 2. So 6.75 times 2 is 13.5 hours. And the question wanted to know, because I scrolled up too far here, how long would it take each of you working alone to complete the job? So we have exactly what we need there. It would take you 6.75 hours, and it would take your friend 13.5 hours. Number 39 is another one where there are several different ways to set this up, but I think the best way to set this up would be in terms of points, because that's really the way that most people will think of their scores on tests. So here's the deal. You have the first 4 tests at 84%. You think you can score 96% on each of the remaining tests. How many consecutive test scores of 96% would you need to bring your average up to 90% for the term? Well, you've already had 4 tests on which you scored 84 out of 100. Now we want to figure out how many tests you would need to score 96 out of to get 90%. Well, percents are always what you want divided by what you have. And what we have here is 4 plus the number of tests, because that's the average. So you'd have all of your test scores, you would add them up, you would divide by how many tests you've taken, and that gives you your average. So this would give us 336 plus 96x over 4 plus x equals 90. And we could put this in the graphic calculator and use the y sub 1 or y sub 2. But certainly this is not difficult to do by hand either, because we could just go ahead and cross multiply and see what we get. So we have 360 plus 90x equals 336 plus 96x. We would subtract 90x from both sides and get 360 equals 336 plus 6x. Then we would go ahead and subtract 336 from both sides and get 6x equals 24. Divide both sides by 6, and there we are. We would need 4 tests to make that happen. So all your scores divided by the number of tests to get you that 90%. All right, now number 41 is about fuel economy. Suppose you drive an average of 15,000 miles per year and your car gets 24 miles per gallon. Suppose gasoline costs $3.60 a gallon. A says, how much money do you spend each year on gasoline? Okay, well, let's think about this. They've got miles up there, and then they have miles per gallon. And if you take miles and you divide it by miles per gallon, that gets you how many gallons? So for A, if we take the 15,000 and divide it by the 24, that will get us 624 gallons. Now we need to take that, 625. That's 625 gallons times $3.60 a gallon, and that comes out to $2,250. A lot of money for gas. All right, let's look at B. You plan to trade in your car for one that gets X more miles per gallon. Write an expression to represent the new yearly cost of gasoline. Okay, well, originally it was 15,000 over 24, but you're going to add an increase, hopefully, in miles per gallon there. And then whatever you get from this, just like in the last one, you're going to have to multiply that by $3.60. And that would get you what you want. And they just wanted an expression, so we're not going to set it equal to anything. And then C says, write an expression to represent your total savings on gasoline per year. Okay, well, if you're saving money, then originally this was $2,250. And you're going to subtract what you get from part B. And then we would be able to figure out the last part of this, but basically I just wanted you to be able to be sure that you could be able to do parts A, B, and C during all of this. So you've increased your gas mileage and you want to figure out how much money basically you're saving, and that would be the amount of money you're not spending of that $2,250. All right, the next one that I have on the list here is number 43. And we're going to solve this equation and check our solution. And we have 15 over x plus 9x minus 7 over x plus 2, and that equals 9. Now, what I'm going to do is look at the fact that my denominators are already in factored form and find my LCD. And my LCD is going to be x times x plus 2. And don't forget that this 9 is a 9 over 1. So we need to multiply each of our fractions here by x times the quantity x plus 2. And in the first fraction, our x's will drop out, and we will get 15 times x plus 2. In the second one, the x plus 2's will cancel out, and we'll get x times 9x minus 7. And the last one, we're not going to get anything to drop out. So we're going to need to take 9. I will distribute the x right now, times x squared plus 2x. So let's see what happens with the math here. Distributing, we get 15x plus 30 plus 9x squared minus 7x equals 9x squared plus 18x. And something really good just happened. We have a 9x squared on both sides. Give me a second to simplify first, and then we can subtract that out of there, and we won't have to factor to solve this. So 9x squared, we have 15x minus 8x minus 7x, which is plus 8x plus 30, equals 9x squared plus 18x. We start to move everything over because we know that to solve means to find the zeros. And like I said, good things happen here. We're now down to linear, which means we'll have one solution. So let's subtract 8x from both sides. 30 will equal 10x. Divide both sides by 10, and we get x equals 3. And again, you should check your solution and make sure it works. This is not a restriction. Our restrictions would have been x can't be 0 and x can't be -2. So you'd put it back up there and make sure it works. But I will tell you, without wasting your time here, that one absolutely does work. Now let me clear some space and go back up there after another one. And that's number 44. So as I'm writing it down, I'm thinking, okay, I need to factor any denominators that are not already factored. I need to change subtraction into adding a negative. Remember, that's really important. One of the most common mistakes made in mathematics is when people forget to distribute the negative. Now, at this point, we need an LCD. And our LCD will be x and x plus 2. So we're going to multiply all of our fractions by x and x plus 2 to eliminate our denominators. Go back and cancel. 2x cancel the x's, negative 1 times x plus 2, cancel the x's and the x plus 2's, and you get negative 4. Let's distribute that negative. And this one's going to be a linear solution here, just one solution. 2x minus 1x is x. Add the 2 to both sides, and we get x equals negative 2. Uh-oh, problem. That would have been a restriction. Our restriction for this one, you can't use negative 2, and we can't use 0. So even though we did all the math right, no solutions. It doesn't work. That's why it's so important that we check these to make sure that our solutions are going to work. Then we have 57. 57 says, what's the solution of x plus 1 over x equals negative 2? So, again, lots of different ways we can do this. I would probably just go ahead and see that that LCD is x. So we multiply everything by x on the top. We'd have an x squared. These x's would drop out, so plus 1. And on the right-hand side, nothing's going to drop out, so negative 2x. Now move everything over to one side. Because this is a quadratic, it has an x squared, and we are going to have to factor to solve. The good news is, this is a perfect square trinomial. There's no common monomial factor, but this is a perfect square trinomial. So our solution would be negative 1. We go back up and make sure that that's not going to be one of the restrictions. It is not. We had an x in the denominator, so 0 would be the bad number. It would make us divide by 0. 58 says, which of the following is equivalent to 6 over 2, and then we have the 6 square roots of 24 over the square root of 3. Yeah, I'm catching myself because I'm already going through that canceling process. 6 over 2 is 3. And then the square root of 24 over 3 is the same thing as the square root of 24 thirds, which is the square root of 8. So this will be 3, and then if we simplify the square root of 8, it'll be the square root of 4 times the square root of 2, which is 2 square roots of 2, and that gives us 6 square roots of 2, which is answer I. So that one, a little review with radicals.